Good morning, good morning. So, picking up right where we left off last time, hmm, we were at the point of we had updated our training sets. We added more data to our training data, our, oh, wait a second. Oh, for a fact, hold on, that's crazy. I know for a fact we worked on that together. Val data, yep, val data, train data. So what is? Oh my God! I just realized why this wasn't working. I had completely forgot to copy over the data from the directory that it was in. So let's do this. So we're gonna remove all of the receiver training data, because what we're about to do now is copy from our Mount C users, Alex, right? Alexander, documents, learn without engineering, and inside of our train data, we have our WR, which we're gonna go ahead and copy everything from there into this current directory. And now I'm insane. I'm so good. Okay, so let's do the same for cornerbacks, right? Go ahead and remove all the data there. CB. Now we actually have 20 cornerback pictures. And then let's hop over to our val data and let's do the same thing. So let's actually just remove everything inside of the val data, make it simple for ourselves. Let's say val data, everything copy to here. We're going to recursively copy those directories over and force it. So now we actually have data to train. Wow. 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 Look at that. Okay. That's actually wonderful. Because we're gonna start with this. So let's head over to our virtual environment like always. We're gonna source out of bin, activate, and then let's bounce back over to source. And here we are. First and foremost, that's what we did, yeah. We created a functions for everything. Model that we're training on is going to be model. Is model, right? Yeah. Okay. So these are current weights. Let's get rid of this actually. We just want to start fresh, right? So we're not going to load. We are going to simply train, get our results, and then get our results, and then we're going to test on the validation information afterwards. So let's see how it does. Okay. So save that over there off of 100 iterations. It's kind of showing only two at a time for whatever reason, right? Or five, no. Okay. Um, that was pretty low. But now let's go ahead and get that loaded so that we can continue training, progressing. Eventually, we get to our 80s. It just keeps on updating those. Bless. I was about to say bless you. So 5 to x. verifying this is how it works. I forget how to. No, that's not right. Is it credit versus? Yeah. So we're just gonna run our program 5 times over. Training.py. All right. And then we're gonna hop over here to the validation next. So let's actually go ahead and just say validate model, model, and we're on this next. Oops, I forgot it's still running. Definitely don't want that. And I mean, we're moving at 80, high 80s, 90% range. At this point, now we know for a fact that if we were to come to this validate, hopefully on all of these new pictures, it'll be able to properly determine and discern which is a receiver and which is a cornerback. So let's give it a shot. A moment of truth. Oh, oh, well, what say you here? We are shuffling too. So if I could just continue to run this, I would assume sometimes it would get it wrong. But from what I'm seeing, that's not the case. We're guessing right every single time. Wow. Wow, 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 wow. Say it ain't so though, right? I mean, it's nice. Like, how can I verify now, right? That's really what I'm looking for. But I mean, looking at the code, you have the model. Yeah, we're loading the file. Hype. Okay. So this should return poorly, which it does. Oh my God. And now if we're loading it, and this is all on new data, right? This is, oh no, never mind. Too good to be true, huh? So let's do this. Training data loader. And let's see off the training stuff now. See, yeah, okay. Okay, okay, okay. We're not doing great. Not doing great at all, honestly. Not doing awful though, but not doing great. So let's say, what is it if we don't load? We're at low 40s, 30s, 50, 55, 40s. Say we do load, we're talking 55, 55, 55, 55. Okay. So this is crazy. I mean, I guess, you're doing the one batch, you're not actually going through it all. Well, no, because this should be 10111. This should be different every time, right? If I'm not mistaken. Yeah, it starts off pretty nice, then it gets hit. It's crazy that it keeps dropping down to 55 every single time. Like, what are the odds? This just doesn't click for me. 0, 1, 1, 0. It's always a different batch, and we're getting some right. Is it guessing the same every time? That might be the issue, right? So here, last one, we're guessing 3 zeros, 1 0. No, it's not. Okay. It's just somehow somebody keeps getting to 55. I don't know. Let's see what happens if we. Okay. So let's properly train first and foremost, right? Training data loader. And this is the validation data loader that we're going to use. And I want to come here. Let's delete this. And then let's sit here for 1,000 runs. Um, and this will be our first training, right? We're gonna run it for 1,000 times. and this will be the first output to our dictionary of the weights for our layers, our convolution layers. Um, I think, first and foremost, I really want to test to see if it's a sense of, is it a place of brute forcing, right? Do I have to just run 10,000 times to get to the point to where it can understand the validation loader? Because the pictures themselves are relatively similar, right? I feel like the pictures themselves are close enough to say the the content size that we have should be enough, right? I don't know how much more I need to add to reach that point, but we'll definitely see. Cool. So we're at 78%, but you have to understand we did start poorly because we were learning at first. So let's run this again. Again, we're gonna run 1,000, but now we're gonna load first and then run it. See how high we can keep this score, right? To me, let's figure out, right? Let's think about it for a second. Let's come here and let's talk. So for training a model, is it the number of different images that is important, or time spent going over the same model somewhere in between? What I like to do, as always, is like theory, right? To me personally, I think you can do both. I think you can either have a sprawling data set, or you focus on just a small amount and repeat those over and over until you get concrete patterns set to be able to then branch off. Both matter, but they do different jobs. Your theory is directionally right, but the roles are not symmetric. Interesting. Number of different images controls generalizations, which isn't really what we're looking for, right? So, okay, I guess. I mean, you can compensate for limited training cycles by doing more training cycles, is what I'm hearing, right? Let's let's run it again. Let's see. Okay, so now we're sitting in the 90s. I would like us to stay in the 90s. That would be nice. Ooh, it is close, boy. That is really close. Okay. Okay. So collect more images ASAP. All right. So how many images would be needed to fully train an AI to this is this is nice, having my training session go while now I feel like we're in a flow of we know enough to keep moving forward without constantly looking stuff up. And I think that makes us dangerous. Right. That makes our learning path a lot faster and a lot sharper. How many images would be needed to fully train an AI to discern between how do you spell discern? Discern? Discern. Discern. Dis. Discern. Haha. To discern between receivers and CPUs. Okay, so we're at 91 now. Let's see. Ouch. Why are we dropping? Oh, okay. Bare minimum to get above coin flip on clean. Oh man. Oh man. All right. So we have a problem. We definitely have a problem. All right. Yeah. Um, I did not expect to come into such a crazy bottleneck so quickly. Um, we're at 92% now. I mean, even now, right? We're training 1,000 cycles and we're barely cracking an extra percent per each run. Let's see. Okay, this started a lot higher, but again, like apparently it's gonna be nothing. So okay, okay. Whew. I assume, yeah, labels are the real cost. Labeling is slow. Yep, yep. Still at 92. We're starting to kind of hit a ceiling. Let's take a look at if you want to validate it now, though. See if we do any better than 55%. 65. Wow. Okay. 65. Look at that. Look at that. Okay. So it works, like we can't deny the fact that it works, especially when we take away the dictionary and it drops to 50, right? It drops to 45, it drops to 50, 55, 40, right? 35. That will never happen if we have our model going. Now you're talking 65, 65, 73. Like this is great in the sense that it's learning. It's awful in the sense that I can't use this for anything because you're wrong 45% of the time. Well, 35% of the time. But this is amazing, right? We can consistently get around 60. We're consistently getting, one, two, three, at least three correct out of a set of five. And, you know, could be better, right? Obviously, but you get your one, two, three, four right here. Okay. I'm impressed. Color me impressed. I forgot that we had already updated the code last video. We already have our functions and they work as expected. So where are we now, right? Where do we sit now? Well, we can do is just run this all together, train it for X amount of time, and then it'll run the validation model afterwards. Um, so what do we do? We have options. Let's talk about the options. We push forward with our 65. Let's say I keep training, and at most I can get it to like a 70% success rate, right? Let's just say, you know, we get it to that point. Um, and afterwards, we have a couple different options. One, we could treat our training data as validation data. You understand? So we can pretend that we have spent the time training. We've created 100,000, 200,000 useful images, and our model is trained extremely well on all of that. And we are at 65 still. I would like to get to like 70, but I just don't know how realistic that is, you know? I really don't. Yeah, it's not looking good. Um, so we can pretend and treat the training data as validated data, validation data. So it'll give us the 90%, 100% score that we're looking for without actually having to go get those 200K images, right? From there, we could still then progress and work on things as if that's working as it should be. So we can, get into the dealing with video. And then inside of a video, oh no, that's the, well, nah. Okay, first let's talk goals, right? First goal, what is the purpose of this exercise? What are we trying to accomplish here? For me, it is to parse and view the difference between, sorry, not the difference between, but to be able to automate in a way reviewing film between one-on-ones with receivers and cornerbacks, right? That is the goal. So being able to first, so for us to now be able to say, okay, we can pretend that we have validation data that is 90 to 100% correct because we trained on it, right? But that doesn't help us do what we're looking to do, right? What we would need to do is somehow take, we would need to grab videos now, really. But even in grabbing the video, I would have to train on the videos for it to track who's the receiver, who's the cornerback throughout the entire rep. That to me sounds like the next move. We've kind of now, what I'm looking for though is the ability to be able to say, here's the start frame, right? Here's the start frame of the image of the video of 00, right? 0 seconds. I mean, sorry, 0 minutes, 0 seconds into this video. Right? Select, put a border box essentially around the. Let me just. I've had a long day. I'm not gonna lie to y'all. So let me make it easy on myself. Okay. So here's what I'm thinking. Since we are at a major bottleneck with the amount of images necessary, here's the goal. Right? We've talked about this already, but let's rehearse. Um, you have video, in this video one, you have your cornerback, and then you have your receiver. WR CB. All right. So within this landscape, this is your video of 13 seconds at second zero, right? So the AI that we're training, my goal is for it to first be able to say receiver and cornerback. So now, if we were to be able to say, okay, X receiver equals X, cornerback equals Y. Now, in any given video at any given time, right, without having to specify or specialize or really discern manually, I can do stuff like, well, if X dot yards traveled is greater than Y dot yards traveled, then do X, Y, Z, right? Whatever logic I'm gonna have to determine, oh, this was a good route or oh, this was a good catch, right? The ball, right? Even once the ball comes into frame, let's say on a pass, boop, 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 boop. So you have the ball coming to be able to say, okay, if well, first you would have to train the AI to find the ball, right? And then you say if the ball, let's call that Y dot hits X. You see what I'm saying? If, or I guess it would be in here. If Y hits X dot hands, right? Then start timer for how long it takes X to secure the ball. And then I get return time. And then with time, I can then say if time is greater than 0.03 seconds, then bad catch. You see what I'm saying? He's like, this is the logic that I'm trying to follow to do what I'm trying to do, right? And so our first step to that to me is next we need to figure out how to do this. This is first. If we don't accomplish this, the rest of it won't work. I have to be able to do this. Um, and I think that's where we're going to pivot to. Uh, to me, this is the next step. And to get there, it's going to be two steps in conjunction, right? One, uh, discern. This is just the word of the day, I guess. Two, objects in one frame. And then two, place. Well, I guess that's placing the border is kind of a part of this, right? So two is really track object. Object, right? So we're gonna discern first and foremost who's who, and then the second thing is like through, from zero all the way to second 13. what are the objects doing during this time? Cool. So that to me is next. Tonight's not the night for that. This is a whole project in and of itself. This is a whole day, hour plus worth of work um, that I'm not really in the mood for right now, if I'm being honest. I expected to come in here and just kind of work on some code, but I completely forgot we already did this. So, uh, yeah, I think it's more important to keep a balance and not necessarily, we have forever, right? We're not rushing. That's one of the first things. This one of the biggest reasons I'm happy I'm streaming this and trying to keep it all under an hour is because it's forcing me not to rush. Um, it's forcing me to go day by day, take it little by little. Whereas normally I would, you know, think about it. I would normally say I'll study for like 5 hours for 3 days in a row, right? So I get 15 hours worth of studying. And then I crash hard. Right? So I crash for until next Monday. So Monday, Tuesday, Wednesday I study. So then I miss Thursday, Friday, Saturday, Sunday. So where these could have been, what was I saying? 4 hours? Oh, I said five. Let's say four. Right? So let's say it's 12 hours. 12 hours that I get. And where these all could have been, 16 more hours to everything. So then I'm at what, 28? 28 hours, which is amazing, right? And if I could have done 4 hours, 7 days straight, 28 hours, that would be amazing. That's not what happens though, right? I burn out, I crash, and then not only do I crash through all these days, I forget. So at least, let's say, half of what I did the first 3 days. So really, by the time I come back around, I've done only 6 hours of work. You see what I'm saying? And on the other hand, what we're doing now is an easy breezy cover girl 1 hour a day max. I don't think that's the max. Simple. I don't know how to say max. How would you say max? Time less than 1 hour a day. Right? And what this is doing is allowing me to say, well, Monday, Tuesday, I do an hour each. Wednesday, let's say I take off. Thursday, hour. Friday, hour. Saturday, hour. Sunday, let's say I take off. I end up with 5 hours for this week. But this is also cohesive with something called spaced retrieval, blah, 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 which we talked about before, yesterday, I think, actually, or last video. And so during the spaced retrieval, this doesn't just become 5 hours. This is actually a very intuitive way to block out things and then make sure uh, meaningful forgetting is happening. Because when that meaningful forgetting happens, you get another chance to encode it, like we talked about, and then go to the next, and then encode it, and then go to the next, and encode it. And then... So realistically, I can easily imagine this 5 hours spread throughout an entire week, turning into something more like seven, maybe eight, 7 to 8 hours. And this is nothing. This is like a walk in a park. I'm relaxing. I'm having a great time. I'm enjoying every second of it because it's a smaller diet, right? But the lifestyle of the person I used to be of saying, yeah, I'm gonna go Monday, Tuesday, Wednesday, 4 hours each day, and then be mad at myself that I wasn't able to do anything for the rest of the week after I've worked for 8 hours, then studied for 4 hours, and then I did 2 hours of homework because I'm still in school. So I'm spending 14 hours a day working and wondering why I'm burnt out the rest of the week. You know what I'm saying? So the stream it's all has been very helpful and pacing myself, and I'm just trying to keep that up. If anyone was curious, But that is genuinely all I got today. And I hope y'all learned something, and I hope y'all have a great rest of y'all day. So catch you on the next one.